Hello friends, now we'll start the exercise 3.6, example number 10 to 18. I had explained all the examples in a very simple language. I hope that you will understood all the problems. This is the second part, and now again there will be the last one part will be there. Then I will start the method of induction and the binomial theorem, remaining exercise for that chapter. Now let us start now the exercise 3.6, example number 10. Now let us start the example number 10. If 20 points are marked on a circle how many chords can be drawn? Now the chord is that join the any 2 points on the circle, that is called the chord. There are the 20 points on a circle. To draw a chord, 2 points are required. Now we have the 20 points. Therefore, the number of chords that can be drawn through the 20 points on a circle, that is equals to 20C2. Find the value of 20 factorial upon 20 minus 2 factorial into 2 factorial. That is equals to 20 into 19 into 18 upon 18 factorial into 2 factorial. These two get cancelled. You will get 10 into 19, and that is equals to 190. Therefore, the number of the chords are 190. Now, next example, example number 11. Find the number of diagonals of an n-sided polygon. In particular, find the number of diagonals when first is n is equals to 10. Find the number of the diagonals of an n-sided polygon. Now, this is the polygon with the side 10. Now, if we join any two points, we get this is the polygon with the side n. If we join any 2 points of the polygon, you will get the side or the diagonal. Side or the diagonal of the polygon. We draw the any points, 4 points. We will join, you will get the side or the opposite vertices. If we join, then you will get the diagonal. 2 vertices can be joined by NC2 ways. Therefore, the total number of sides and the diagonal that is a NC2. But there are the n sides of the polygon. There are the n sides of the polygon. Now what's happening here? That is the total number of the sides and the diagonals is equals to NC2. But there are the n sides in the polygon. Therefore, total number of the diagonals is equals to NC2 minus n, because we will subtract the sides of the polygon. Then we will get, that is NC2 minus n. Now here n is equals to 10. Therefore, the number of diagonals can be drawn is equals to n 10C2 minus 10. That is the 10 factorial minus 10 minus 2 factorial minus 10. That is equals to that is equals to 35. Therefore, n is equals to 15. Therefore, the number of diagonals that can be drawn is equals to 15C2 minus 15. That is equals to therefore you will get that is equals to, after the normal calculation is there, you can perform that calculation. That is equals to 90. When n is equals to 12, now again the substitute, that is the number of the diagonals is equals to 12C2 minus 12. Therefore, that is a 12 factorial minus 12 minus 2 factorial into 2 factorial, and that is a 10 factorial into 2 factorial. Normal calculations are there, 12 into 11 into 10 factorial into 2 factorial, 10 factorial get cancelled. Therefore, that is a 66 minus 12, and that is equals to 54. Therefore, the 54. Now again, this is a polygon with the side n is equals to 8. Therefore, the n points are there. Therefore, the number of diagonals that can be drawn, that is a NC2 minus 8 minus n, that is the 8C2 minus 8. You can perform that. Now 8 into 7 into 6 factorial upon 6 factorial into 2 factorial, that is you will get 28 minus 8, and that is equals to 20 diagonals can be drawn. Now the question number 12. There are the 20 straight lines in a plane so that no two lines are parallel and no three lines are concurrent. Determine the number of points of intersection. There are the 20 straight lines in a plane so that no two lines are parallel and no three lines are concurrent. A plane consists of 20 straight lines. No two of them are parallel and no three of them are concurrent, means they do not intersect at a single point. They are not parallel. All lines are there. Not a single line is parallel to another line. No three of them are the concurrent. Two lines can intersect at a one point and every two lines intersect at a point that is single point. That is, a two line can intersect at a point, at a one point, and every two line intersect at a single point. The number of points of intersection of the 20 straight lines, that is nothing but the 20C2. Now find out the value of this. That is, in this case, no two lines is parallel, no three of them intersect each other. Therefore, the 20 factorial upon 20 minus 2 factorial upon 2 factorial. Now explain this. 20 into 19 into 18 factorial upon 18 factorial, get cancelled, you will get 190. Now the example number 13. 10 points are plotted on a plane. Find the number of straight lines obtaining by joining these points. If there are the 10 points on a plane, find the number of the straight line obtained by joining these points. That is, no three points are collinear, first of all. That is, if we take the 10 points and that is, not a three of them are the collinear. That line is drawn by joining any two points. Any two points from the given 10 points. Therefore, the number of straight lines, that is equals to 10C2 10 factorial upon 10 minus 2 factorial into 2 factorial. Now we can extend this. 10 into 9 into 8 factorial upon 8 factorial into 2 factorial. These two get cancelled and you will get, that is 45. Therefore, now next is B. 4 points are collinear. Now this is interesting examples. Out of them are the 4 are collinear. Therefore, we will find out first of all 10C2, then minus 4C2, and 1 add for the 4 collinear points. A line is drawn by joining the 2 points from the given 10 points. Therefore, the number of straight lines, that is equals to 10C2, 10 factorial upon 10 minus 2 factorial into 2 factorial. You will get 10 into 10 factorial, 10 into 9 into 8 factorial upon 8 factorial into 2 factorial. That is a 45. Now the next is, but 4 points are collinear. That is, they do not form the lines by selecting the 2 points. Therefore, we have to subtract from 45 these 4C2 and add only 1 line by using these 4 collinear points. That will be the answer. We will reduce the lines by 4 points and add 1 line because the 4 collinear points will give the 1 line, which is due to 4 points. Therefore, by 4 points, the number of lines are 4C2 upon 4 factorial, 4C2, 4 factorial upon 4 minus 2 factorial. Normal calculations are there, 4 into 3 into 2 factorial, and that is you will get 6. Therefore, the number of distinct straight lines is equals to 45 minus 6 plus 1, that is equals to 40. Therefore, we can draw the 40 lines. Now question number 14. Find the number of triangles formed by joining 12 points if no 3 points are collinear. Therefore, this is simple one. That is, no 3 points are collinear. Therefore, we can form, to form the triangle we require the 3 points. Therefore, we can form, that is a 12C3. A triangle is formed by selecting 3 non-collinear points Therefore, we can choose 3 points from 12 points. Therefore, that is a 12C3 is equals to 12 factorial upon 12 minus 3 factorial into 3 factorial. That is equals to 12 into 11 into 10 into 9. 9 factorial into 3 into 2 into 1. These two get cancelled. That is equals to 2. That is the 220 triangles can be drawn by using these 12 points. Now the next is 4 points are collinear. Again the same thing is there. We will subtract this. We will form the triangle from this. That is a 4C3 subtract. Now the given 12 points can be form 220 triangles. And by using these 4 points, how many triangles will be formed? That is a 4, C, 3. 20, if and only if out of the 12 points, 4 are collinear, then we have to subtract. Triangle formed by these 4 collinear points. See this here. That is a triangle formed by the 4 collinear points. That is a 4 4C3, 4 factorial upon 3, 4 minus 3 factorial into 3 factorial. That is equals to 4 into 3 factorial. These two get cancelled. You will get 4. Therefore, the triangle formed by 12 points, out of which 4 are collinear, is equals to that is a 12C3 minus 4C3, that is a 220 minus 4 factorial upon 4 minus 3 factorial into 3 factorial. That is equals to 216. Now the question number 15. A word has 8 consonants and 3 vowels. How many distinct words can be formed if 4 consonants and 2 vowels chosen? This is very simple. That is the 4 consonants and can be selected from 8 consonants and 2 vowels, 2 vowels can be selected from 3 vowels. Therefore, the number of words with 4 consonants and 2 vowels that is equals to 8C4 into 3C2. Now we'll perform the calculation. That is a 8 factorial upon 8 minus 4 factorial into 4 factorial into 3 factorial, 3 minus 2 factorial into 2 factorial. That is 8 factorial, 4 factorial, 4 factorial into 4 factorial. 3 factorial into upon 1 into 2 factorial. Normal simplification is there up to the 4 factorial. We can extend. That is 3 into 2. It is not necessary to extend this 4 factorial into 4 into 3, and this is 3 get cancelled, but still okay. No problem. I had done at that time this calculation. that is a 210 words can be found. Now each of these word contain 4, that is the 6 letters, and can be arranged in 6 ways. That is permutation is here now. That is a 6 factorial ways. Therefore, the total number is equals to total number of words can be found that is a 210 into 6 factorial. Now there will be a big number. That is a 210 into 6 into 5 into 4 into 3 into 2 into 1. That is 1,51,200. Find n if NC8 is equals to NC12. Now we know the formula, that is a NCR is equals to NCN minus R. By using this formula, this is the important formula, that is a NC8 is equals to NC n minus 12. That is, we have changed NC 12. Therefore, NCX is equals to NCY. Then X is equals to Y. Therefore, 8 is equals to n minus 12. Therefore, the value of n is equals to 20. The value of n is equals to 20. 23C2n. Now I'm changing that. That is it. Here, see this here. 23C3n is equals to 23C2n plus 3. Now also here we know that the NCX is equals to NCY. Then X is equals to Y. Now what is here? 23C3n is equals to 23C2n plus 3. That is equals to, now 3n is equals to 2n plus 3, and that is equals to n is equals to 3. Therefore 23C, or we can also the another method, n is equals to 3 we are getting here. Now 23C3n is equals to 23C2n plus 3. Now again by using this formula, that is NCR is equals to n C n minus R. Now equate these two. That is 3n is equals to 23 minus 2n minus 3. That is 3n plus 2n is equals to 20. Therefore 5n is equals to 20, n is equals to 4. Therefore there are the two answers, n is equals to 3 or n is equals to 4. Third, 21C6n is equals to 21 C n square plus 5. Now again by using the formula, that is the NCR is equals to n c n minus r. By using this formula we can calculate here. That is a 21c 6n is equals to 21 in bracket 21 minus n square plus 5 and solve this now. This is again we will get the quadratic equation. Therefore 6n is equals to 21 minus in bracket n square plus 5. Therefore n square plus 5 plus 6n minus 21 is equals to 0. Now this is a quadratic equation. The factors are n plus 8, n minus 6, n minus 2. Therefore n plus 8 is equals to 0 or n minus 2 is equals to 0. Therefore n is equals to 2. N is equals to minus 8, n is equals to minus 8 is not possible. Therefore n is equals to 2 here. Not possible, n is equals to 2. This is the final answer. Now this is my answer. Answer in the textbook is different. Now you will say, sir, your answer is different one. If you are agree this, then you write. If you do not agree, then don't write. Answer in the textbook is different. I had solved in my method. Now next, fourth one, that is a 2nc r minus 1 is equals to 2n r plus 1. Now here 2n r minus 1 is equals to 2n r plus 1. Always use our formula, that regular formula, NCR is equals to n c n minus r. Now equate these two terms, you will get the answer. That is r minus 1 is equals to 2n minus r plus 1. That is r minus 1 plus r plus 1 is equals to 2n. Now 2r plus 2n plus 1 minus 1 get cancelled here. Therefore n is equals to r. This is the answer. Now next is nc n minus 2 is equals to 15. Then find the value of n. That is again by using the formula NCR is equals to nc n minus r. Now by using this, that is you will get nc 2 is equals to nc n minus 2, that is equals to 15. Now see this, it's an important one. Now see, that is this is the formula, that is the nc r is equals to nc n minus r. Means what here? This is the 2 here. Therefore we take here nc2. Now see this again. nc2 is equals to 15 and that is equals to nc n minus 2, that is equals to 15. Now see this nc2 is equals to 15 because this number is smaller one. Therefore we can perform the calculation. Therefore n factorial upon n minus 2 factorial into 2 factorial is equals to 15. Normal calculations are there. That is, see this here. N factorial, n into n minus 1 into n minus 2 factorial, n minus 2 factorial into 2 factorial, these 2 get cancelled, divided by this 2 gets to multiplied with the 15, then you will get 30. And what will happen? N into n minus 1 is equals to 30. Now see this here. These two get cancelled. You will get n into n minus 1 is equals to 15 into 2, that is equals to 30. Therefore, n into n minus 1 is equals to 6 into 5. Then by comparing, you will get n is equals to 6. See this again here, the value of n. This is the value of that. Again, it goes very fast. That is equals to, therefore, n is equals to 6. This is the value. N is equals to, by comparing here, n means 6, n minus 1, that is a 5. Now the next is number 17, question number 17. Find x if NPR is equals to x into NCR. Now NPR is equals to x into NCR. Therefore, x is equals to NPR upon NCX. Now evaluate this. N factorial upon n minus r factorial upon n factorial upon n minus r factorial into r factorial. Now n minus r factorial and n factorial get cancelled. You will get x is equals to r factorial. Now see this multiplied and reciprocal. Okay. This n factorial get cancelled. N minus r factorial get cancelled. You will get x is equals to r factorial. Now see this here. X is equals to r factorial. In this way, we have completed the example number 10 to 18. I hope that you have understood all the problems, whatever that I had explained. Now we'll see in the next video and for the remaining examples.